So this lesson is on factoring quadratic equations. So in one of the previous videos that you may have looked at on forms of equations, we found that a quadratic relation can be represented by three different algebraic representations, one of them being standard form, which is what this looks like, and the other one being factored form, or also known as zeros form or X-intercept form, which is this one. And so these two actually represent the same quadratic relation, and I can actually show that. So in the previous video I showed that by showing a table of values and how those tables of values were identical. Well, what I'm going to do is I'm actually going to take this form and I'm going to expand it and simplify, and I will show that it will become this form. So if I take y equals x minus 4, x plus 2, and I put it into my chart, so I have x minus 4 down the side and x plus 2 across the top, and I fill in my chart. I have x squared, and I have 2x minus 4x and minus 8, and so in here is my expanded form. And I'm going to write that out again. So x squared plus 2x minus 4x minus 8. And now I'm going to simplify, and I have x squared minus 2x minus 8. And so you can see that these two are the same. What I've done is I've changed from factored form into standard form. Well, when we were looking at forms of equations and what information we could get from standard form, we found that standard form wasn't very useful. There was only two things we could get from standard form, and that was the y-intercept and what direction the graph opened. And that was about it. Whereas with factored form, we could actually get all of the properties. We could find the x-intercepts, the y-intercept, the vertex, the axis of symmetry, the direction of opening, the maximum or minimum value. So you can get that all from here. And so what we're going to look at in this lesson is going from this form, so standard form, into factored form. And again, one of the reasons it's called factored form is because these two brackets here are the factors of this. So when I multiply those together, I will get this. So when I multiply x minus 4 times x plus 2, I will get this form, which is what we showed here. So how we're going to go about looking at how to factor is, since factoring is really the reverse of expanding and simplifying, what we're going to do is we're just going to look at a couple of examples of expanding and simplifying using the chart, because what will happen is we're going to notice patterns within the chart that is going to help us be able to figure out how to factor. All right, so starting with the example on the left, we're going to create our chart. Helps if I select the pen. Alrighty, so here's our chart, and we have 2x plus 1, and we have 3x minus 2. And now we're going to fill in our boxes, and so we have 6x squared minus 4x plus 3x minus 2. So that's expanded. So writing that out again, I have 6x squared minus 4x plus 3x minus 2, which is 6x squared minus x minus 2. So we have our factored version and our standard version of that one. So now working on the example on the right, again, I'm going to create my chart. And so I have x plus 4 and x minus 1. And I have x squared minus x plus 4x minus 4. And writing that out, I have x squared minus x plus 4x minus 4. So that gives me 3x plus 3x minus 4. So I now have the standard form and the factored form of each of these quadratic relations. So when we're factoring, instead of going in this direction, what we're doing is we're going to end up going in the reverse direction. So we're going from standard form to factored form. And how we can easily do that, because in some cases it's not completely obvious, is we look for patterns within the chart. And one of the patterns that we know, there's a couple of things we know, is that we know that the x squared term always goes in this box here. So the top left-hand box. The constant term, this one here, and that includes its sign, so this one here, always goes in the bottom right-hand box. And the other thing that we know is that the middle term here, so this minus x and this plus 3x, is actually divided up somehow, or split up. I'm not going to use the word divided because that implies an operation, which isn't true, into these boxes here. So what's important to see is that we know the first term, top left, last term, bottom right, and the middle term is, another way to say it, is decomposed or split up into here. We know that these two have to add up to this. These two have to add up to this, and we see that here, and we see that here. So those two terms will add up to this term. These two terms will add up to this term. And this pattern here that we see is really, really important, because what we're going to be doing is working from the inside out to figure out what the factors are. One of the other patterns that we should be able to notice is that if you look at this and this, if you multiply those two together, you get negative 12x squared. If you multiply these two together, you also get negative 12x squared. Kind of interesting. So I'm just going to, so 6x squared times minus 2 equals minus 12x squared, and minus 4x times 3x also gives us minus 12x squared. And that's an interesting pattern, and that pattern actually always holds. So this times this is equal to this times this. And if you'll notice, we have like a little multiplication symbol in the middle. And as you can see here, the same thing holds. X squared times minus 4 is minus 4x squared, and 4x times minus x is also minus 4x squared. So this idea that the boxes on the diagonal will multiply to the same value. And that's a really important pattern, because that's what this pattern that we've just talked about is the one that we're going to be using in a process to work backwards, to go from here all the way up to here. And that's because we know how to fill in these two boxes, but then how do we fill in these two boxes? And using this pattern, this multiplication pattern, as well as knowing that they have to add up to this middle term, or this middle term, is the thing that we're going to use in order to completely fill in the box. All right, so now we're going to work through this example. We have y equals 2x squared plus 3x minus 9. And how this is going to work is we are going to create our chart, but instead of filling out the information on the outside of the chart, we're actually going to be starting by filling in the information on the inside of the chart, because that's where standard form comes from. It's the inside. So I know that the 2x squared has to go into the top left-hand box. So I know I put the 2x squared there. And I also know that the minus 9 goes into the bottom right-hand box. So I have minus 9. And I also know that this plus 3x, it has to fit in here, but it has to fit in so that it's distributed amongst these two. So we know that these two have to, and I'm going to write this off to the side, that has to add to 3x, but it also must multiply, and this was the pattern we saw before, to what these two multiply to, which is minus 18x squared. So it has to add to 3x and multiply to minus 18x squared. And normally, because the variables, although yes, those matter, in the case what we're doing is we're actually just looking for the coefficients in front of the variables, because that's the value or numbers that we need the terms to multiply to and to add to. So I need two numbers that will multiply to positive 3, or sorry, add to positive 3 and multiply to minus 18. And usually how I approach that is I write out all the factors of minus 18. And as I'm writing those factors out, what I do is I see if they will add to 3. So possible factors of minus 18 are, well, there's the two that we already have, which are 2 and minus 9. Now if I add those two together, 2 plus minus 9 only gives me minus 7, which is not positive 3, so I can say, well, I know that doesn't work, so I'm going to cross that one off. So then another possible factor is 3 and minus 6. And so if I add those two together, I get negative 3. And I think, okay, well, I need positive 3. So I know this doesn't work, but it actually kind of helps give me a hint, because, well, they add to negative 3, but I need positive 3. So what if I just switch the signs on these two? So if I had negative 3 and 6, so negative 3 plus 6 gives me 3, and so that means we're good. So that's a check mark. So I know I can use these two here to complete my chart. So I will, and this honestly doesn't matter, so I'll have minus 3x here, and I'll have 6x here. So now what I need to do is I've got the inside the chart all filled in. Now what I can do is I can fill in the outside of the chart. So fill in this space, this space, this space, and this space. And how I do it is by something called common factoring, which is where I look for whatever's common to both these terms, and I'm going to factor that out here, or divide it out. So if I look along here, what's common to both these terms is just x. So that's coming out this way. I'm common factoring out in this direction, and I get x. Now, common factoring out this way for the next, whoops-a-daisy, for the next row, I'm just going to erase this. for the next row is I look at what's common to both of those. What's the biggest thing that I can divide into both of these evenly? And it's 3. So I'm going to common factor out a 3. Then I'm going to go up in this direction, look at this column, and I say, okay, what's the biggest thing that I can divide evenly into both these two terms? And it is 2x. So I can divide out a 2 and an x from both of these two terms. Then finally, I look at this column and I say, what's the biggest thing that I can evenly divide into both of these? And it's -3. Now, one of the questions you might be asking is well, there's a negative here, but I have a +3 here, and how did I know that this should be -3 and this should be +3? And what we say, there's this rhyme, it says the sign stays with the line. So because this is negative and it's closest to the solid line, the negative gets factored out. But if we look here on this side, in this direction, it's positive, so the positive gets factored out. And here it's positive, so positive gets factored out. And same with this one here. All right, so now it looks like we actually have our two factors. We have x plus 3 and 2x minus 3. But one of the things that I always do is a little check, because we know that if I worked in the reverse direction, so if I was expanding and simplifying, these two need to multiply to this. So 2x times x is 2x squared. These two should multiply here, so x times -3 is -3x. These two should multiply to 6x, and they do, and 3 times -3 is -9. And so I know that this is right because I've checked my work. And that's what's really nice about this method, is that it's got a built-in check. So I have found my factors, and my two factors are x plus 3 and 2x minus 3. And so this is the factored form, or the zeros form, or x-intercept form of this particular quadratic relation. And that's how we factor. So it's not as complicated as most people think. So what we'll do is I'm going to put another example that I would like you guys to do, and then we'll take it up. All right, so in this example, what I would like you to do is we have y equals 3x squared minus 13x plus 4, and this is where I would like you to pause the video, and I'd like you to try this yourself. And if you get stuck, you can start the video to help you, but I want you to try this on your own. Okay, so taking this up, I'm going to make my chart. And knowing what I have to fill in, I know I have to fill in my 3x squared here and my 4 here. What I don't know is how or what to fill in here and here, right, into the bottom left and the top right box. What we do know is that they have to add up to -13x, and we also know that they have to multiply to the same thing that these two multiply to. So 3x squared times 4 is 12, and so we know that not only do they have to add up to -13x, but they also have to multiply to 12x squared. So I always write that off to the side so I can keep that in mind. So they got to multiply to 12x squared, and they have to add to -13x. All right, so factors of 12. Well, we have 3 and 4. Well, those only add to 7, so that doesn't work. So I'm actually going to cross those off. And then I have 6 and 2. Well, I know that those don't work because that adds to 8. And if I did the negative versions of those, of -6 and -2, it would just be -8. So then we have 12 and 1. Well, that sort of works because it adds to 13, but what we need is -13. So this doesn't work perfectly, but we know then that we can just, if we had -12 and -1, these would work because those do add to -13. So I'm going to fill those in, and again, it doesn't matter where you fill them in, so because it will still factor properly, and this is negative x. Okay, so I've filled those in. Now what I have to do is common factor each row and each column, and that means we pick the biggest number that is evenly divisible into, if I start with my rows, these two. So what that ends up being 3x, because 3 is divisible by 3, and 12 is also divisible by 3, and we have an x and we have an x. So this is 3x. Common factoring in this direction, the biggest thing is negative 1, and again this is where we have the sign stays with the line. Going up in this direction, our columns, what's common to both, again, is just x. And in this direction, what is common to both is negative 4. So, now this is where we do our little check. 3x times x is 3x squared. 3x times minus 4 is minus 12x. Negative 1 times x is negative x, and negative 1 times negative 4 is 4. It works, then we know this is correct. So we have y equals x minus 4 times 3x minus 1. So this we know works. Now, one thing that students often ask me, well, does it matter which of these we write first, whether it's x minus 4 or 3x minus 1? No, it doesn't. It's the same thing as 3 times 4 is the same as 4 times 3. So it could also be written as 3x minus 1 and x minus 4. It doesn't really matter. You get the same answer. So here I have another example, 3x squared minus 3x minus 6. And one thing that we haven't seen yet is this idea of checking for common factors before we even start the factoring process. And it's something that we should always be doing is making sure that if we do have a common factor, that we factor that out. So in the case here, if we look at all three terms, so 3x squared minus 3x minus 6, all of those are divisible by 3. And so what we can do is we can actually common factor that out, the 3, before we even begin. And so that's what it looks like. And if we don't do that, we're actually going to run into problems when we try to factor. So now what we'll do is we'll factor what's in the bracket. So I keep this as brackets. And I'm going to fill it in appropriately. So we have x squared here, and we have minus 2. So then we know when we're looking at what we have to fill in here, those two have to multiply to negative 2 x squared, but they also have to add to this middle term, which is negative 1x. So we need two numbers that will multiply to negative 2 and will add to negative x. So factors of negative 2 are either 2 and negative 1, which gives me positive 1, so that doesn't work. Or I have negative 2 and positive 1, and this works here because that adds to negative 1, so I put that in, and again it doesn't matter where I put it. So that's an x, and this is just an x. So common factoring the rows, what's common to these two here is just x. What's common out here is just 1. Common up the column, again, is just x, and common in this one is negative 2. So writing this in factored form is y equals 3 x minus 2 times x plus 1. And we leave the 3 out here. That's completely valid. So this will be factored form of this. So now I'd like you to try this one. This is negative 6x squared minus 7x plus 3. And see if you can factor that one. So pause the video, try it, and then play the video to see if you've got it correct. Alrighty, so now this is another one of those. I've got a negative here, and the best thing to do is to common factor that out. You should actually be checking to see if I can common factor something from each of these, and the one thing you can common factor is the negative 1. So we're going to common factor out the negative 1. So I'm left with 6x squared plus 7x minus 3. And so when I write that out again, I have a bracket and then my chart. So we know that the 6x squared goes here. We know the minus 3 goes here. Next thing we need to do is to find two numbers that are going to add to this. So that goes in here, but also multiply to minus 18. So we have two numbers that multiply to minus 18 x squared, and they are going to add to 7x. So we know we need to have a positive and a negative because those are the numbers, because the multiplication is negative. And so when I look at the factors of minus 18, I'm going to go with 9 and minus 2, and actually those work. So 9 minus 2 gives me 7, and 9 times 2 gives me minus 18. So there we go. So I'm going to put 9x here, minus 2x here, and I'm going to start common factoring. Common factoring my top row first. Common to both of those is 3x. Common across here is negative 1. There's always a common factor. So if you don't see something off the bat, it's most likely 1. And then don't forget the sign stays with the line. So here the sign, the negative, stays with the line, and common to both of these is just 1. Common factoring up the columns, I have 2x, and common factoring up the final one is just 3. So now I'm going to do my check. Did I actually do this properly? So 3x times 2x is 6x squared. 3x times 3 is 9x. Negative 1 times 2x is negative 2x, and negative 1 times 3 is negative 3. So we have 2x minus 3 and 3x minus 1. So as mentioned, really the purpose of factoring is to go from standard form to factored or x-intercepts or zeros form. And the reason that we're doing that is because from that form we can actually find all of the properties of a quadratic relation. And so I just want to show what I mean by that. So if we're given this particular quadratic equation in standard form, what I want to do is look at, okay, well, if I want to state all of the properties of this quadratic relation, so the properties are, properties, those will include the y-intercept, the x-intercept, or intercepts, they can have 1 or 2, the vertex, direction of opening, and the axis of symmetry, and the max or the minimum value depending on the direction of opening. And so that's what we're going to do. So if we look at this one, well, I know that we can find out what the y-intercept is and what the direction of opening is, based on the information there. And so we might as well go ahead and do that. So the y-intercept, and this is when x equals 0. So I have y equals 0 squared plus 3 times 0 minus 10, which is equal to minus 10. So we know that the y-intercept is at 0 minus 10. The direction of opening, so the DOO, the direction of opening is up. And we can tell that because the a value, or the number in front of the x squared, is a 1, and it's positive 1. So a is equal to 1, and since it's positive, that means that the direction of opening is up. All right, so now it's the x-intercepts and the vertex and the axis of symmetry and the maximum minimum that are really difficult to get from this form. And so what we need to do is change forms. And the form that we learned how to change it to in this particular case is a factored form. So that's what we're going to do, because we know we can get all the information from that form. So this is for the x-intercepts, and this is when y is equal to 0. So what I'm going to do is, first thing is to factor it. So I have y equals, and I'm going to do my chart. And I know that the x squared has to go here. The minus 10 must go there. And then what we need to do is, in order to fill in these two, is we know that they not only have to add to 3x, they also have to multiply. 1 times negative 10 is negative 10. So multiply to negative 10 x squared and add to 3. So thinking about it, I'll say that factors of 10 are negative 5 and 2. So negative 5 and 2. Those add to negative 3, so I know that's not going to work, but that means that 5 and negative 2 should work because those will add to positive 3, so we're good to go. So I have minus 5x, and I have 2x. I'm going to common factor my rows first. So the top row, what's common here is just plain x. What's common in the bottom row is 2. Common in the first column, again, is x. And common in the second column is negative 5. So the sign staying with the line. So now I have my factors, which are, I'm going to bring this up here. Our factored form is y equals x minus 5 times x plus 2. Alrighty, so for the y-intercept, or x-intercepts, this is when y is equal to 0. So I'm going to set this to 0. And in the video for forms of equations, we looked at how we got the x-intercept. So we know that if either of these two factors are 0, we'll make all of this 0, and so that means that we've satisfied the equation. So I set this factor to 0, so x minus 5 equals 0, and I set this factor to 0, x plus 2 equals 0, and I'm going to solve. So this is x equals 5, and this is x equals minus 2. And so those are my two factors, or those are my two x-intercepts. So if I substitute in 5 here, 5 minus 5 is 0. 0 times 7 is 0, so that works. Or if I substitute in negative 2 minus 5 is negative 7, and negative 2 plus 2 is 0, so negative 7 times 0 is 0, and that works. So now we have to decide what we're going to find next. Well, we've got, let's cross off what we have. So we have the y-intercept, we have the x-intercepts, we have the direction of opening, and the last three things we need are the axis of symmetry, the vertex, and the maximum or minimum. Well, we know that the x-intercepts, these guys here, are symmetrical points, And so we know that the axis of symmetry has to be halfway between those 2 points. And so that's what we'll find first. We'll find the axis of symmetry. I'm going to use a different color here. So the axis of symmetry. So that's when we add the two x-intercepts together. So 5 plus minus 2. And we divide those by 2 because that's the halfway point or the midpoint. So 5 plus minus 2 is 3 over 2. So that's 3 halves or 1.5. So we know that the axis of symmetry is where x is equal to 1.5. So now we have the axis of symmetry, so we can check that one off our list. And now all we need is to find the vertex and then the maximum or minimum. So the vertex, well, we know that the axis of symmetry ends up being the x-coordinate of the vertex. So we can actually use that with our equations to find out what the y-coordinate of the vertex is and solve it that way. So I'm going to move on to a clean slide or a clean sheet of paper, and we will continue on. Actually, I just discovered something. I can just slide this up. So that's what I'm going to do. I'm going to carry on using this piece, but the grid is just going to end up moving up and will be on a blank piece of paper. So I'm just going to scroll this up. So this is for the vertex. So, and I can use either factored form or the standard form. So we have x minus 5 times x plus 2, and I'm going to sub in where x is equal to 1.5. So I have 1.5 minus 5 times 1.5 plus 2. And that is 1.5 minus 5 is minus 3.5. And 1.5 plus 2 is 3.5. And, whoops, moving that up again. That will equal minus 12.25. So we now know the vertex is at 1.5 minus 12.25. Now we have the vertex, so we can actually cross that off our list. So I'm going to scroll this back down. Oh, hey, that's interesting. That stayed there. So I won't do that. All right, so we know what the vertex is. And now what we need to find is if it's a maximum or minimum. So we know that we found the direction of opening was up, so that means the vertex is the lowest point, so it's a minimum. So we know we have a minimum here. And it's always the minimum or maximum y value. And since our vertex, again, is the minimum, this will be our minimum y value. So that is where y is equal to minus 12.25. So there we go, is a prime example of factoring. What was the purpose of factoring? And the purpose was, here we go, we'd actually determine all of the properties of the quadratic relation that we were given, but we couldn't do it from the form that we were given, which was standard form. We actually had to convert it to factored form in order to do that. So we'll just do one more where, again, I will give you an equation, and what I want you to do is determine all of the properties. So here we have y equals minus 5x squared minus 5x plus 30, and I would like you to find the y-intercept, the x-intercepts, the vertex, direction of opening, axis of symmetry, and the max or min value. So please pause the video, try it, and then you can check your work once you're finished, or if you get stuck, you can play the video until it helps you get things resolved. All right, so for the y-intercept, this is when x is 0. So I substitute that in. I have minus 5 times 0 all squared minus 5 times 0 plus 30. And that is going to give me 0 minus 0 plus 30, which is 30. So I have the y-intercept. Now I have to find the x-intercept. So I'm going to go woohoo, check mark. And then we have the x-intercepts. Now again, we can't determine that from this particular form of equation. We have to change it. So the form that we know how to change it to is factored form. So I'm going to do that now. Now I'm going to write this out again. So if I have to move up the page again, then I have it so I can see it. So what we should do is we always should check to see if I can common factor, and I can. If you'll notice, each of these terms is divisible by 5, and not only is each term divisible by 5, I've got this negative here. So I'm actually going to common factor out the negative 5. So this gives me minus 5 x squared plus x minus 6. So now I'm going to factor what's in the brackets. So I'm going to, I have minus 5. And I have my set of brackets here. And I have, filling in the chart, I know I have x squared needs to go there, and minus 6 needs to go here. How we fill in these two has to be, it has to add to 1 and multiply to negative 6. So it's got to multiply to minus 6x squared, and it has to add to x. And if we look at that, that will be plus 3 and minus 2. So I have plus 3 and minus 2. If I multiply, again, I get negative 6, and if I add them, I get negative 1, so I can put those in any order. It doesn't really matter. So now I'm going to common factor out my rows, and so my top row, common to both of those, is just x. Common to the bottom row is minus 2. Common to the first column is x. And common to the second column is 3. So if I do my quick check, x times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, and negative 2 times 3 is negative 6, so I know that's right. So bringing that up here, I know that I have minus 5, x plus 3, and x minus 2. So that is my factored form of the equation. So now, setting y to 0, I know that if any of these terms are 0, it's going to make the whole thing 0. So what I want to do is find a value for x that's going to make this one 0, and a value for x that was going to make this one 0. So I do that by setting each factor to 0 and then solving. So I have x equals minus 3 and x equals 2. So those are my two possible x values that will make the whole thing 0. Minus 3, so minus 3 plus 3 is 0. So minus 5 times 0 is 0. And then 0 times minus 5 is 0. When x is 2, I have minus 5 times 5 is minus 25 times, this will end up being 0, which is 0. So those work. So I now have my x-intercepts. So now what I need to find is, so I can check mark that one off. So I've got my x-intercepts. If we want to look at the direction of opening, in this case, this is my a value. My a value is negative. That means the direction of opening, it's sad, it's in a negative mood, so it opens down. So direction of opening, a is equal to -5, therefore down, because it's a negative number. All right, so we have our direction of opening. So then what we need to do is find our axis of symmetry, our vertex, and our maximum or minimum value. So because we again have our x-intercepts, those are symmetric points, and we can use that to find the x-coordinate of the vertex, or the axis of symmetry. And so I'm going to do that by moving this up, and then using the page below. So this is for the axis, so I should really might do this in black. So we have the axis of symmetry. So the x-coordinate, or the equation for the axis of symmetry, will be halfway between -3 and 2, which is -3 plus 2 is -1/2, which is -1/2, or you can write that as -0.5. All right, so we have our axis of symmetry. So now we can use that to find our vertex. And how we can use that to find our vertex is I can substitute in x equals -0.5 into either one of the two equations, either the standard form or the factored form, and we can find out what the y-coordinate of the vertex is. So last time I believe I used factored form, so this time I'm actually going to use standard form, just to be a little different. So we have y equals -5 times -0.5 all squared -5 times -0.5 plus 30. All right, so that is -5 times 0.25 plus, because -5 times, or a negative times a negative will give me a positive. This will be 1/2 of 5, which is 2.5, plus 30. Then -5 times 0.25 is -1.25 plus 2.5 plus 30. And when we add all of that up together, I get 31.25. So that means my vertex is at -0.5, 31.25. And we would expect this. This makes sense. And the reason that it makes sense is that my y-coordinate of the vertex is positive, and we know that it opens down, and so that makes sense because in order for it to cross the x-axis, this would mean that this here would have to be above the x-axis. So this makes sense. So since our parabola opens down, or our quadratic relation, the graph opens down, then that means that our vertex has to be a maximum. So in this case, we'll have a maximum value, and the maximum, oh, that's not how you spell maximum, is always the y-coordinate of the vertex, so that is y equals 31.25, or the minimum depending on the direction. So those link together. All right, so this is how you can use factoring, or this idea of switching forms from standard form to another form, so that we can find out the properties of a quadratic relation. And that's really important when we're answering real-world questions, such as if a ball's being kicked, or a ball being thrown, or a rocket being launched, or a diver diving into a swimming pool, is that we can answer questions about the path of this object if our equation that we're given is in standard form. And all we are doing is algebraically manipulating it in order to find out information about it.